Okay, great. Thanks very much. It's great to be here. So I'd like to introduce you to our work on pretouch sensing for mobile interaction. This was a really fun project for us. Oops. Hang on a second. There we go. Why am I? Sorry, fumbling with things here. Yeah, and it's one of those papers where pretty much everybody contributed to it. I actually do have a couple blanks left in my slide here, so if anyone else wants to be on the paper, just talk to me after the session. But in all seriousness, Seongkook, who hails from KAIST, and he worked with me at Microsoft Research last summer, was really instrumental in bringing this project to fruition. So everything good in the talk is his, and all the screw-ups are mine, so you can blame them on me, any shortcomings or limitations. So here we see what is perhaps the most pedestrian and boring scene ever in mobile touch interaction, just a hand holding a device. This is something you've probably seen a million times. Probably even just looking at it now is bringing you to tears. It's been a long day. It's okay. You can cry a little bit. But often these sort of scenes pass us by, but we never really stop and look at what's going on. So how do people really use their hands in these kind of situations? So if we look closer, there's all kinds of behaviors and little things hiding in plain sight. And so that also calls into question of, well, what is it that we really mean when we say that someone's touching a device? And in particular, if we step back so that we can appreciate how natural human grasping behaviors are analog and continuous, then why is it that we boil down the entire vocabulary of mobile touch interaction to this flatland of an XY coordinate on a screen? So as designers of mobile touch, and as of course also as users of these techniques that we've created, we've all been living in this world of these little discrete state transitions, finger up, finger down, that are defined by this sort of impoverished on-screen two-dimensional view of the human hand. And it's a view that it's definitely been useful. But it's also arguably been holding us back from advancing touch further, and mobile touch in particular, in new directions. So perhaps our key observation in all of this is the following, and that's that much of what characterizes touch on a mobile device starts before contact and originates from beyond the confines of the screen. So users, they'll first, whip out my device here. They'll first grip their device, often in their non-preferred hand. I got to mention that because Yves is in the front row here, and he'll hit me with the stick if I don't bring up his model. And then they reach for the screen with their opposite hand, often the preferred hand. Or they might interact with it with a single thumb, or they might come with a pinch. But I am touching my device now, even though it's not being sensed by the system. So we can kind of go from this view of touch as a point at a particular instant in time, and expand that out to this whole world that surrounds the device that's above and around the screen. And most critically, let's see, let us think here. And most critically, that's before the touch itself. Yeah. So this treasury of contextual detail, which is the combination of both hover and grip, that we collectively are referring to as pretouch, has been lost to mobile interaction. And note that carefully. I'm talking about both hover and grip. So in our work, these come along for free from the same sensor that's unified with the touchscreen itself. I also wanted to emphasize that the term pretouch is not ours. It's been used before. Most notably, Michel used it in her Medusa system. But you can also find other examples where people have used this. I'm actually not sure of the first person to use the term pretouch. If someone knows, please tell me.
We explore pretouch sensing for mobile interaction. This emerging modality uses a self-capacitive touchscreen to sense multi-touch above the screen, as well as grip around the outer edges of the device.
Okay, so that gives you a quick sense of what's going on here. So the particular sensor that we're using is based on the Vogel sensation technology. You can look at their website. They have nice details that explain how it works. It contains just a standard 16:9 matrix of capacitive sensors. But the way it drives the capacitance sensing is a little bit different than the standard projective capacitive solutions that are the industry standard right now. But this self-capacitance mode of capacitance sensing, it's actually a really well-known technique. It's been around for quite a while. And I just want to categorically state that I am not an expert in this technique, so I can't answer detailed technical questions about that aspect. And indeed, the hardware is not what our contribution is here. It's using this sensor and looking at how pretouch sensing can afford these context-appropriate mobile interactions. All right, so you've probably heard about hover or seen examples of control gestures in air in various projects, like the old Microsoft tabletop devices, for example, had this capability to sense the multi-touch hover above the screen. So these clearly are not new in and of themselves, but I do want to set apart the whole general philosophy or sort of the viewpoint that we approach the project with. Because most of the examples of this type of sensing in literature, but of course not all of them, but many of them, are for issuing commands or doing some type of intentional control. And the focus of pretouch isn't on these type of overt or foreground gestures, but instead pretouch is more primarily about the background of the interaction, sort of what happens before the touch, the framing and the context of it. I also wanted to emphasize that this is maybe a slightly different than the standard Chi paper in that it's more of a design space approach. We're exploring this emerging modality of pretouch sort of breadth first across a number of techniques and possibilities, but we're not really going depth first into any one technique in exhaustive detail. So we're just trying to sort of explore this modality and see what some possibilities for it are. So to illustrate this design space, we explored 3 general areas. The first is we called anticipatory reactions, and this is where the interface is contingent in some way on grip and or the hovering information. Secondly, we looked at retroactive ways of interpreting the touch, and this is where the approach trajectory can form and perhaps modify the semantics of what the touch means to the system. And thirdly, we looked at what we called hybrid touch and hover gestures, and this is where you use some combination of fingers touching the screen, and then there's a simultaneous aspect that's in the hover state. And I'll show examples of all of these. So first, for anticipatory reactions, the one I want to start with is called the Adlib Interface. And on these, I am going to go into this one in a little bit more detail because I think it's one of the more interesting examples we discovered.
Proactively adapt the interface to the current grip and the approach of the fingers. For example, our prototype video player has an Adlib interface that spontaneously presents interactive elements just in the nick of time. Initially, there is no interface. The video is the focus of attention. But when the hand approaches, this indicates a change in context, and so the controls fade in. Yet, the interface recedes into the background when the user moves out of proximity. However, if the user holds the device one-handed, only a subset of the controls come forward, and in a manner particularly suited to the thumb. Instead of sliders, the user dials to scrub through the timeline, or adjust the volume. While holding the device in the other hand brings the controls to that side instead. With the second thumb, a richer set of options becomes available, and is distinct from a pinch to zoom, which again fades out single-finger controls.
Okay, so that gives you a sense of some of the different types of approaches we can sense and react to. So the key ideas here are namely that when the fingers are away, there is no UI and there's only the content. And this is sort of an absolutely critical part of this technique because not only does it put the focus on the content, which of course is where the user's attention should rightfully be most of the time, but it also means that the interactions always start from sort of this clean slate or a neutral configuration from which we can layer in carefully selected UI elements. And then as the finger approaches, that suggests the user's intending to engage with the device. And so we fade in the interface. And we do that currently quickly over about 200 milliseconds. I'm sure our lag is also adds to that. So I could certainly use the latency hammer to test that. But we fade in very quickly. And then we also, when the finger goes away, we later fade out. And that's a different timing threshold. Because there, of course, the idea is that we want to just withdraw the interface very gradually in a way that doesn't draw your eye or draw your attention. So it's just kind of like this, a waiter kind of just getting out of the way. Let's see. Oh, and I also want to point out, we did also fade with making the fading level directly proportional to how far your finger is above the screen. And that can also kind of work, but it also is one of those things where it it's not quite as stable. It tends to feel a little more flashy, or it kind of just catches your eye more. So we felt that wasn't quite as satisfactory. But there might be a way to design it differently than we tried that would work for that. But we felt that just having sort of these fixed animations was the best way to do it. And of course, they also are interruptible. So if you start approaching and then move away, it'll just withdraw, like that kind of thing. So all those little details are handled nicely. But the other key idea here is that since we're fading in the interface anyway, we can take the liberty then to fade in these context-appropriate controls, like the one-handed version, the two-thumb version, and so forth. And so in fact, we have multiple grip and hover contexts. There's about a half dozen of them that are supported in the UI. So there's sort of all these different states that the interface will morph between just based on what it's seeing from the grip and the approaching fingers, how many fingers there are, what's the pose of those fingers, and so forth. So there's a lot of richness there in what we could do. And potentially there's others we could sense as well that we currently don't. And we even adapt some of the control gestures, like with the dialing example. And to be clear here, it might not have been so obvious because you're looking from above. It's not always clear in the video when the finger's actually touching or not. Here, the finger is in contact with the screen, so it's just a standard on-screen dialing control. Because we feel that touch is great for control. We did play with some things where you could use the hover state to manipulate things, and generally those are dumb ideas, so I don't recommend it. So one other example of an anticipatory reaction is this example we call calm revelation.
We also explore Pretouch as a way to provide a calm web browsing experience, free of clutter. Only when the user approaches do the hyperlinks reveal themselves, and they do so in a rich way that feathers off with the contours of the finger. And when the user comes in with multiple fingers, the interface again recognizes this as a distinct state. This affords self-revelation of multi-touch gestures, such as providing hints for a two-finger swipe to switch tabs. With a simple mode switch, the Pretouch channel can also be used to refer to and highlight content during collaboration.
Okay, and in that particular example, we're just using the hover information. That demonstration doesn't use the grip information. So in terms of some of these retroactive examples, there's many situations that arise in mobile pointing that have some inherent ambiguity to them. You often see things like the little Twitter timeline that's mocked up on the left side of the screen here, where there's kind of these large objects like the individual tweet, and then there's tiny targets embedded within them. So you kind of end up in these ambiguous situations where you're going to, if you just want to open the tweet, you might be close to that retweet button, and then which control should the system respond to. So we tried using the actual approach trajectory information as a way to disambiguate that. This is an example of, this is just an instance of a particular user pointing at the screen. So what we notice is that for large targets, typically the user will just point in sort of this ballistic motion where they just kind of quickly dive to the screen. But then when it calls for precision, you see more of this kind of slow, gradual approach. And so we're trying to take advantage of that and use that to distinguish what's going on.
Pretouch can also act as a backchannel that augments touch events. Hence, a rapid tap that just happens to land on a small target can be discounted. Or, fine adjustments that end up on a large target can be mapped to a nearby small control instead. As another example, a touch preceded by rapid lateral motion can immediately be interpreted as a flick, whereas a touch preceded by precise motion instead triggers text selection.
Okay, so it gives you a couple little tricks where you can layer a little bit more semantics onto the touch just based on that approach trajectory. So for the final category, these hybrid touch and hover gestures, here's an example of that.
Pretouch lends itself to hybrid touch plus hover gestures, which combine on-screen touch with sensing fingers directly above the screen. For example, we can enhance selection by pressing on an object, while bringing another finger into range to call up options. This allows efficient commands at a comfortable and convenient location. However, since we can also sense grip, when using just the thumb, the technique gracefully degrades to one-handed use. Hybrid touch also has potential for games, such as a soccer game.
Okay, yes, we had a little bit of fun too. All right, I'm not sure what that was. So it's just a picture of the menu there. I'm running out of time, so I'm going to jump ahead here. So our evaluation was just a very informal one where we just basically had people try out the techniques and get some basic reactions. I don't really have time to go through that in detail, but like for instance with the Adlib interface, we got a lot of comments of like things like, I like the transparent controls and they're predictive, of where my finger's approaching, or that it feels very natural to my hand and allows a single hand in a comfortable position. People especially gravitated towards that one-handed use case. They felt that they really appreciated the device could kind of meet them in the middle there and not make them stretch across the whole device to reach something. We did get some other comments, like some people felt that the controls should perhaps appear a bit more quickly. We also had, for instance, there was one user that had fairly large hands, and when he reached onto the screen one-handed, he tended to land more towards the center, and the controls sort of appear at this default position near the edge. So potentially you could attempt to adapt to the hand size, but that might require a more precise prediction of where you actually expect the user to land than we're currently generating. Overall, so these one-handed adaptations stood out, but all the techniques sort of had people who liked them. In fact, it was sort of a spread. Like there was no one technique that sort of universally stood out. The one problem area we found is that, particularly with this idea of separating the ballistic from fine taps, we found that the way we're doing that right now is great for some users, and for other users it basically didn't work very well at all. And partly that's because the current heuristic we're using does not consider the grip, which we kind of realized after the fact and we're kicking ourselves. But in the actual user test, people were using it both ways. So if you use it with your thumb, for example, it just wasn't tuned for that. And we also feel that per user adaptations may be helpful. So just to conclude,
We've demonstrated how Pretouch affords interfaces that are more responsive to the fine-grained context of use, that are easier to reach and more comfortable to use, and that engender more communicative, more expressive, and more entertaining ways of interacting through touch. Taken as a whole, our exploration of Pretouch hints that the evolution of mobile touch may still be in its infancy, with many possibilities, unbounded by the flatland of the touchscreen, yet to explore.
All right. So, yeah, this is Seongkook. I wanted to mention that he's coming on the job market at the end of this year. He was fantastic on this project. In fact, he was so fast and implemented so well that he actually had it done for Kai last year, and it just was me writing up the paper. It was slowed us down. So he's amazing, and I definitely, if you're looking for a good hire for your department, he'd be great. So with that, I'll be glad to take any questions.
Ken, that's great work. Short question is how these techniques are possible on regular capacitive touchscreens. Is it because self-capacitance touchscreen are much more sensitive to pre-touch?
That's exactly it. Like
okay.
This Hrvoje sensation device is really sort of a hybrid between the standard capacitive touchscreens and this self-capacitance technique. So there's a little bit, if you read that page I pointed to on the slides, it has some great detail about exactly how that works. But in fact, the reason that the projective capacitive is the industry standard right now is because it does not respond to touches above the screen, which is what you want most of the time, right? Because you don't want to be close to your screen and suddenly have random links firing off in your web browser and that kind of thing. So they intentionally suppress this above screen regime. But with this sort of new take on capacitance sensing, which it can also be integrated right into the touchscreen. I don't know ultimately what that would cost to manufacture. Maybe that's a limitation at some point. But I do think that this is sort of, there's been a number of things that, like, if you go to venues like the SID, the Society for Information Display, like pretty much every year you'll see people demonstrating these, some kind of 3D touch technology for the various touchscreens and displays. So I really see this as kind of the way the industry is moving, whether it's this particular sensor or something else. So it's just, there's so much being invested in touch that I think ultimately we are going to have this type of information, whether it's through this sensor or something else.
As a handhold, leaving the cost aside, when the touchscreen is that sensitive, are there forcing possibilities that would hinder the consistency of the proactive UI?
I imagine they are. Like with the particular device we have, it's just an engineering prototype, so those kind of details haven't been refined. So you can sometimes get false touches with it, or sometimes it'll see your fingers touching when it's not. So there's calibration issues, but it's not a commercial device, right? So it's just this prototype. So those kind of things would have to be worked out in a commercial realization.
Yeah.
Yeah.
Your design space exploration is always inspiring, as always. It reminds me about 20 years ago, one of the your projects I liked really a lot was the idea of a touch-sensitive mouse that otherwise you can hide a lot of UI elements, and only when you touch it would display them. There's some similarities to here, except at a different state. I wonder if there's similarities you can draw, and also it was thought a very practical technique that didn't never seem to be deployed anywhere. Like,
right.
Were there similar?
Right. Obviously that particular one that she was referring to was on a desktop situation. So we had a mouse that was coated with conductive epoxy, and when you put your hand on the mouse, it would fade in the toolbars. So yes, in fact, I am just taking all my old ideas from 20 years ago and I'm sticking them on mobile devices. But it works out pretty well sometimes, so I recommend it. All right. Thanks very much.